Hey, what's up guys? Welcome back to the video series on the small CNC mill, Smalley. So it's been a long pause, and I'm getting back into working on the machine. And here I'm just showing a few clips on the side milling action. It's a 12mm end mill, five flutes. Great for side milling, terrible for end milling. The vibrations it produces are absolutely astronomical. So showing a few clips on the nice chips. Now I've been working on the machine on and off for the past few months, and I've been off of it for about 2 weeks. But I am almost to a state where I can add the linear guides and the motors in and actually turn the thing on. It won't work because some of the parts are still missing. I'm still waiting for them. But in theory, in about maybe 2 or 3 weeks, I should be able to make a video of it actually moving under its own power. So this video is mostly focused on the gantry pieces. Now, if you checked the last video, the idea is that X and Z axes are basically, will not combine, but they're running off the same platform. So the gantry is basically the x-axis that moves, right? But attached to it is also the z-axis, so it moves up and down as well. Sorry. And I added a few braces to the frame, although I don't think it was necessary. I think it looks better. So here again, I'm facing the other side of the gantry. This is a 20mm cutter, 6 flutes. Very nice cutter, very nice and stiff. Good results overall. And I think here it's taking about maybe 1mm deep cut. And I believe the next clip is going to be it taking about a 3mm deep cut, which it also did pretty well. Sorry, my cat is going crazy right next to me. Okay, and here's going to be the 3mm deep cut, side milling, and the plate thickness is either 8 or 10 millimeters, something around that. Okay, and I was actually thinking about changing the machine a little bit, because, you know, why not create more problems for myself, and to actually move the y-axis linear rails up top. So instead of having the bed move, now all the 3 motion systems, which is the X, Y, and Z axis, would be on the top plate. The only benefit that I can see for that is I could possibly run, I'll say relatively high pressure coolant, but that's about it. And I'm worried that the overhang on the gantry will actually create problems for me, but I need to test it out a little bit. And here the 20mm end mill, which has 6 flutes, is taking I believe 15mm deep cut. And the step over was initially, I think, 3, and the second one is a little bit lighter. I think this is 2 now, since the chips were a little bit too blue for my liking. And unfortunately, this end mill is now extremely dull, but it did last me for a very, very long time, and I think I got many hours of milling out of it, so that's good. But yeah, anyways, I'm thinking of moving all the motion systems up, and I need to test it a little bit and see what the deflection might be at the maximum extension point. So that would mean that the bed of the machine is now not moving but stationary. So I've seen, and you know, I've seen some experimental machines that work like that, but there has to be a reason why most of the machines don't have all three axes moving, and I'm guessing it's something to do with the stability and the strength of the whole gantry system. Because to make it stiff enough, you have to make it heavy enough, but then you need to upsize the motors, the ball screws, the linear rails, all that kind of stuff, and then it becomes heavier, so you need bigger ball screws, blah 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 blah. So it's a vicious circle in that sense. And here the 20mm end mill is doing a 40mm deep cut, and step over is 1mm. It did pretty well, I think, overall. And if you notice, the top surface and the side surfaces, they are both machined, so they're square and flat, because those are going to be the mating surfaces for this piece that you're seeing on the computer screen right now, which is the Z-axis. And that is going to be connected to the gantry. It's made from nice steel plates. It's pretty heavy. And the idea was that I would bolt it to the gantry piece that I was machining earlier, and I could sort of guarantee that everything would be square, and you know, because that seems to be the biggest problem right now, because of the I don't have any CMM machines or anything like that to measure squareness. I sort of have to make everything square on the mill and then basically hope that everything stays square while I'm milling it. And you know, of course, it would be nice if I had a working surface grinder, which I'm currently building, but none of the pieces would fit on there anyway. I would need a pretty large surface grinder for that, which again I don't have access to. So we sort of have to make do with the tools and the capabilities that we have access to. And I don't know if I've already told everybody, but the motors are going to be NEMA 23. The ball screws are 12mm, 4mm step, because let's be honest, I don't need that high rapid, because it will run out of space long before it can spin up to the required speed. So and the linear rails are Hiwin HGR15s, and I will say that I was sort of I don't want to say I was warned, but I was told that you should change them out for larger ones, even though, you know, it's a relatively small machine. But I can say that I should have gone for 20s or maybe 25mm linear guides, because while they do run nicely, I can sort of tell that they're basically they should be bigger. That's all I'm gonna say. And here you can see the first handwritten CNC program by me, which was to face the bottom. And I take a facing cut, I move the Z-axis up, I wrap it back to the start point, and I feed the Z down and over 10mm, so it moves diagonally, and then I take the next facing cut. And the feed was 250mm, and the depth was 1mm. So I'm just doing the finishing facing cut, so I can have it to the right dimension. And in just a few seconds you will also see how the gantry and the Z-axis plate, how they match up. And they were bolted with M6 bolts, because I think that's already more than enough to secure them. Okay. And there we go. So you can see on the bottom lower side, you can see the 2 bolt holes, and that's where the bolts go in. And I have 2 at the top as well behind, but I didn't unfortunately show it, so I'm going to show it in the next video. So anyways, this has been a fun little machine build, infuriating as well. And here's a picture of my cat. Thank you very much, and please check my next video as well. And if you liked it, please subscribe and like. Thank you very much. Bye-bye.